Hello everyone, welcome to Differential Questions by Alex, and that is me. Alright, so today's topic is going to be called Undetermined Coefficients and then also the Superposition methods. Alright, so let me go into the type of equation that we're going to be dealing with. Alright, so we have a non-homogeneous equation because we now have a g function here. Previously, this g function was a 0 on the previous section, and so that's what we dealt with in the previous section, where the a, the b, and the c are just numbers. That's what I'm saying here. And previously we had a 0, but now in this section we're going to be dealing with the more general case where we actually have just a g function there. And then the only catch is that the g function has to be of a specific type. So it can be a constant, it can be a polynomial, it can be an exponential function, or it could be a trig function, a simple trig function, or a sum or product of this function that I mentioned here. So we still have a lot of type of functions for g that we have allowable. And so what we're saying here is that when we have this format, then we can use the method that we are going to present today. All right, so let me go into the first question just to give you a feel for what the method says. All right, so we have a differential equation, and here the g function is given by 7e to the 4x, okay? So now for the question A, and what I've done is I've broken down the problem into pieces, that way it's manageable. And so for the first question, question A, we want to find the complementary solution to the differential equation. So what that means is that we're going to look at the homogeneous part of this. So this is going to, we're going to make it equal to 0. And so we're looking at the homogeneous equation. And now this is a review from the previous section, which we have to remember, how do we solve this homogeneous second order linear differential equation? So what we do is we're going to guess at the solution. We're going to guess that the solution is going to be an exponential function. And at this point, we want to know what is the m. So we make this guess, and now our task is to figure out what the m is. So what we do is we need to find the y prime and then y double prime, plug that into our differential equation, homogeneous differential equation, and see what we get. And then once we do that, so let me just do that for the first, for this first question. So we're going to get m squared e to the mx plus 5m e to the mx plus 6 e to the mx is equal to 0. All right, so now every term has an exponential, so we can kind of cancel that out. And then we are going to get the auxiliary equation, which is m squared, oh, this is a minus, this is supposed to be a minus. So minus 5m plus 6 is equal to 0. So we now have an auxiliary equation, which is an algebra equation. So we change the red equation, which is the non-homogeneous equation, to a homogeneous equation. And now this differential equation, we change it into an algebra equation. And then this we can factor. This one's possible to factor. So this is going to be n minus 2 and then m minus 3 is equal to 0. So that means that we get two numbers for this piece. So m is equal to 2 and m is equal to 3. So those are the two numbers that are the values for the m that we were looking for. Remember, we assumed that the solution was an exponential, and then we were trying to figure out what the m is, and now we have. So that means that our solution to the homogeneous problem is the following. We are going to write down the fundamental set of solutions, which is e to the 2x, and then the second solution is going to be e to the 3x. So that's our fundamental set of solutions. And our complementary solution is going to be the combination of these two functions. So c1e to the 2x plus c2e to the 3x. And that is the complementary solution that we were looking for. So again, this is just the solution to the homogeneous equation that we're looking at. All right, so now one thing to keep in mind is the complementary solution and then the g. So kind of focus on those two pieces of information from the problem. Now we're going to go into part B. Part B is asking us, does the g function belong to the complementary solution? Does the g function belong to the complementary solution? So let me write down the complementary solution that we just wrote down. So c1e to the 2x plus c2e to the 3x. Okay. Yeah, c1e to the 2x and then plus c2e to the 3x. So that's the complementary solution. And now the question is, it's basically asking us, are there any values for c1 and c2 such that this yc function becomes the g function? Okay, this is our g function that we're trying to focus on. And then nothing, we don't care about the 7, we care more about the e to the 4x. And so we're asking, are there any values for C1 and C2 that can change the YC into the G function? And the answer to this problem is no. Okay, that's because the G function has the 4x, and our solutions have the 2x and then the 3x. Okay, so the answer to this problem is no. Just keep that in mind for the second question. Okay, so now no to this question means that this is a easier problem to deal with. Okay, and then we'll figure out what that easier part means on question number 2. All right, so now for the part C, now we're going to be dealing with the entire differential equation, the entire non-homogeneous equation, where we are dealing with the G function that's given to us to be 7e to the 4x. And so now we are going to now again guess what the solution is going to be. Okay, so here we are going to make a guess, and we're going to guess, I'm going to guess that the particular solution is going to be e to the 4x. Okay, and that's because my G function is of this format. It's of the exponential to the 4x, e to the 4x. And so that's why I'm going to make this educated guess that the solution should be a number a multiplied by e to the 4x. And now our task is to figure out what the a equals. Okay, so the task is to figure out what the a equals. So what we're going to do is we're going to plug in the derivative, which is 4a e to the 4x, and also the second derivative into the, so this is 16a e to the 4x, and we're going to plug in these 3 pieces of information into the differential equation. So we're going to plug all this into the differential equation, and then that's how we get the following. So let's write this down. So this is going to be 16a e to the 4x minus 5, and then the y prime became a 4a e to the 4x plus 6a e to the 4x is equal to 7e to the 4x. All right, so now we're going to simplify whatever we can here. All right, so first of all, notice that every single term on both sides of the equal sign has an exponential part to it. So yeah, there's an exponential part to every single term, and so that means that we can cancel that out, and so we're going to get 16a minus 20a plus 6a is equal to 7. All right, so now let's just do the simple arithmetic on the left side. So 16 minus 20, that's negative 4. Negative 4 plus 6 is positive 2a is equal to 7. And so the a is equal to 7 divided by 2. All right, so notice that this part is purely algebraic. We just do a little bit of arithmetic, and then we solve the a to be 7 over 2. So remember that in the very beginning of this problem, we said that, oh, we're going to guess that the solution to this problem is of this format, but we did not know what the a was at that point. But now we do. And so that means that our particular solution to this problem is going to be 7/2 e to the 4x. So that's the particular solution to the differential equation that's given to us on the very top. So that's our ODE on the very top, and then we found the particular solution to be 7/2 e to the 4x. All right, so now one more part to this question. Now this question is asking us for the general solution. Okay, so the general solution to the differential equation, to a non-homogeneous differential equation, is going to be of the following format. We have to add the complementary solution plus the particular solution to the problem, and we found those individually. Okay, so the complementary solution was c1e to the 2x plus c2e to the 3x. That was the complementary solution, and then we just found the particular solution, which was 7 over 2e to the 4x. And now this is going to be our general solution to the problem, to the original differential equation. All right, so number 2. All right, so just double check on the problems. Yeah, it should be 7 over 2. All right, so now that's the first example, and then there was the question part B was asking you, was the G solution part of the complementary solution, and the answer to that was no. So keep that question in mind, because that's going to appear again in part 2, question 2. So let me go back to the beginning here. So here we want to talk about finding the complementary solution to the given differential equation. So let me put this in blue. And so that means we have to look at the homogeneous equation, And then actually this is the same homogeneous equation that we dealt with before. So we had the homogeneous equation, and then we got the auxiliary equation to be m squared minus 5m plus 6 is equal to 0. And we got the two numbers to be m is equal to 2 and then m is equal to 3. So we did the work in the previous problem. And then that means that our fundamental set of solutions is going to be y1 is equal to e to the 2x and y2 is equal to e to the 3x. And what that means is that the complementary solution, which is c1y1 plus c2y2, this means that our complementary solution looks like this. So c1 e to the 2x plus c2 e to the 3x. All right, so that's the complementary solution. And this is the same thing that we did on question number 1. Just repeating the story. But now what I want to say again is that we want to focus on two things. One, we want to focus on the complementary solution, which is the solution to the homogeneous equation. So this is the homogeneous equation, and we find the solution to that, which we call the complementary solution. Now the other thing that I want to focus on is on this g function. Okay, so look at the g function and notice that e to the 2x appears in the complementary solution. E to the 2x appears in the g function. Okay, so now that is related to the part B question here. So the part B is asking us, is the g function, does it belong to the complementary solution? And so let me write down again the complementary solution, which was c1 e to the 2x plus c2 e to the 3x. And now the question basically is asking us the following: are there any choices for c1 and c2 such that it will give us the g function? Are there any values for c1 and c2 that if you choose those values, it will make the yc function to be equal to the g function? And in this case, yes. So choose c1 to be 1, and then choose c2 to be 0, and then that means that your complementary solution reduces to, oh, actually not a 1. Make this a 7. So 7e to the 2x, and then this is your g function. That is your g function. So this is saying that the answer to this question is yes, the g function is part of the complementary solution. Okay, so whenever we have this, we have to be careful on what we are going to guess or what the solution is to the original big problem, the original differential equation. All right, so just keep that in mind. All right, so here we are. So we have the non-homogeneous differential equation where we have this g function that does belong to the complementary solution, and then we want to find the particular solution. So we are going to guess at the solution here, and then so if you hadn't done the work before, you would guess that the particular solution should be a e to the 2x. So you could make the guess that the solution should be a number a multiplied by e to the 2x, but it just happens that in this case it does not work. Okay, it does not work. So what we're going to do is we're going to make another educated guess, and then there is some reasoning behind this, but it's a little bit lengthy, so I'm just going to give you the setup here. So we're going to guess that the solution is of this format. Okay, so what's the difference between this and the previous guess? The difference is that we have this extra x being multiplied. So having this extra x makes the function a little bit more complicated. Remember that now that we are making this guess, we want to plug in the first derivative also, and also the second derivative into the differential equation, and then we are trying to figure out what the a is. Okay, so what I've done here, because it takes a while to write down the derivatives, we have to do the product rule. Okay, so we have to do the product rule, and the guess is that the solution should be of this format, and we have this extra x on the guess. All right, so here's my first function and here's my second function. So first function multiplied by the derivative of the second function plus the second function times the derivative of the first function. So that's my first derivative. We have to use the product rule, and then you have to use the product rule again twice to get the second derivative. Okay, so I'm putting a box on where you have to use the product rule the second time here. So double underline blue means the product rule again, and the last box is just a regular derivative. So you can double check here my derivatives. So we made the guess, which is in red. We need to find the first derivative, and then we need to find the second derivative, and then we have to plug in this information into the differential equation that we have at the very top, and then we're going to make it equal to 7e to the 2x. We're going to make it equal to the g. So that's what we have here at the bottom. Okay, so let me just like underline a few things here. So this part, yeah, this part is my second derivative. Okay, so that's my y double prime is what I'm plugging in here. Now my stuff inside the parentheses in purple, that is this thing here, which is I'm going to plug in my y prime. That is my y prime, and that is what I'm putting here next to the -5. And then lastly, I have my ax e to the 2x, which was the original guess of the solution. And that goes here, and so that's what I plug in there. All right, so just kind of explaining where things are coming from. And again, we are plugging in things into the differential equation, and then we are making it equal to the g function. We make it equal to the g function. And now we have to do the algebra. Okay, remember that our goal now is to figure out what the a is. At this point, the goal was to find the a. And so now we have to do a little bit of algebra. And so let me put this in black. And let me rewrite this as being 4ax e to the 2x, and then plus 4a e to the 2x. I'm going to distribute the -5, and that's going to be a minus 10a x e to the 2x. Distribute this to the other one, so that's going to be a minus 5a e to the 2x, then plus 6a x e to the 2x, and this is equal to 7e to the 2x. Okay. All right. So now we want to combine like terms. All right. So now I'm going to underline the things that have x e to the 2x, x e to the 2x, x e to the 2x. So now I'm going to look at the coefficients in front of those. So 4a minus 10a plus 6a. So 4 minus 10 gives you -6. -6 plus 6 gives you 0. So that means that these things that I'm putting in red are canceling out after you do the arithmetic. So that's a good thing for us. So what's left over? So we have the 4a e to the 2x minus 5a e to the 2x. So that gives us a what? A negative a e to the 2x. And then this is going to be equal to this 7e to the 2x. All right, so we have this gray box here on the bottom. I'll put it in a box because now I need to move up here. So cancel out the exponential, and then you get negative a is equal to 7. Or in other words, we get the a is equal to -7. All right, so remember, think back to what we were looking for. We were looking for what a is equal to because we had made an initial guess to what the solution of the non-homogeneous equation was. But we needed to know what the a is. Now we do. We now know what the a is. And so now we know that the solution to this non-homogeneous differential equation is going to be -7e to the -7x e to the 2x. Let me rewrite it up again. The particular solution is -7x e to the 2x. All right. So we found the particular solution, and yes, it seems a little funny that we're guessing at this point, but that is what we do. This is called the method of undetermined coefficients because we do not know the coefficient a. So we do all this process, this algebra, to figure out what the a is, the coefficient a. And then once we do that, we find the solution to the entire differential equation on the very top. All right, so that's all I have for question 2. Actually, no. So this is the particular solution, and now I want to combine this with the more general question. The general question is find the general solution to the entire differential equation. So the general solution is going to be the combination of the complementary solution plus the particular solution that we just found. And so if you remember, this is going to be c e to the 2x plus c2e to the 3x plus, and I gotta remember this is actually was a minus. This was a minus 7x e to the 2x. Yep. So this is going to be the general solution to the non-homogeneous differential equation. All right. So that's example number 2. And on example number 2, question number 2, we have the situation where the g function. We had the situation where the g function was part of the complementary solution, so we had to make a little bit of a adjustment to the guess, which was an x. Right? All right, so now let me give you a different type of problem. So same setting, same method, but now we are in the case where we're going to have a polynomial. So this function that we have here for the g function, so this is the g function, the function is a polynomial. And so now part A goes back to the question of finding the complementary solution. And for the part A, we always go back to the homogeneous, okay? So y double prime plus 4y is equal to 0. Okay, so we have this homogeneous equation, and so we want to solve this homogeneous equation, and so we make a guess here. So the guess is that this is going to be an exponential function, and then we want to know what the m is equal to, and when we plug in the y function, we get the auxiliary equation, which is m squared plus 4 is equal to 0. So do the algebra, and then you get this auxiliary equation. So now, what are the factors of this? So this turns out to be m is equal to plus or minus 2i if you do the algebra. Okay, so m is equal to plus or minus 2i. And so technically what we get are the following solutions. So y1 is equal to e to the positive 2ix, and y2 is equal to e to the negative 2ix. So those are the two functions that form your fundamental set of solutions, y1 and y2. The catch here is that we have the I number, and again, I here for this class, it refers to I is equal to the square root of -1. I have to repeat this because sometimes when you deal with other type of engineering, like electrical engineering, you have to use different variables. All right, so just a quick note on depending on your application, sometimes you do want to work with these functions that have the I number, and sometimes you don't. So for our purposes, we don't want to work with these functions that have an I, and so what we do is we change these functions. We change the functions so that we don't deal with the I function, and we talked about that in the previous section. So we said that we're going to create a new y1 function, which is going to be cosine of 2x, and y2 is equal to sine of 2x. So review the previous section to see how we get this y1 and y2 in purple, which are related to the blue y1, y2. All right, so these are your y1, y2, and so that means that we can write down our complementary solution to the differential equation. So the complementary solution is equal to c1 cosine of 2x plus c2 sine of 2x. Right, so that's the complementary solution, the combination of cosine 2x and sine 2x. That's the complementary solution. All right. So now let's go into part B. Part B is, as before, is asking us, is the g function, which is a quadratic function, does this belong to the complementary solution? And let me write down the complementary solution a little bit more clear this time. So this is a c1 cosine of 2x plus c2 sine of 2x. So now the question is, are there any values for c1 and c2 such that the yc will become this quadratic function? And the answer to this question is no. The complementary solution is in terms of the trig functions. There's no way that these trig functions, for no matter what values for c1 and c2 you choose, you will never get this polynomial, this quadratic polynomial. So the answer is no, which that's a good thing for us. Okay, that's a good thing for us because we don't have to be too careful with our guess for the solution to the original differential equation. All right, so that's part C. Part C is asking us to find the particular solution to the differential equation. So here we are going to make a guess, and then the guess that we are going to make is the following. We're going to guess that the particular solution is going to be a quadratic function. So ax squared plus bx plus c. Then we have to find the derivative. So at this point, we make this guess, and then we want to know what the a, b, and c are equal to. We don't know what these three numbers are, a, b, and c. So these are our coefficients. These are our undetermined coefficients. That's what it's called, the method of undetermined coefficients. So in order to figure out the a, b, and c, we need to find the derivative of the particular solution and also the second derivative, plug that information into the differential equation, and then we are going to somehow figure out what the a, b, and c are. All right, so I'm going to do that, but I typed up the derivative. That way it's a little bit easier to manage. And then not only that, I also plug in this into the differential equation. So let me just kind of highlight where the information is going. So the second derivative is here. So that's the second derivative, and then that's where this is coming from. Okay, so that's 2a. Now the y, this is just the regular y function, which is in the very top. That goes into this parentheses, so that's what I have here. And now on the other side, I just write down, copy and paste my g function. So that's my g function, copy and paste it, and then that's how I have my equation at the very bottom. Now we need to solve for a, b, and c in this algebraic equation. So let me distribute this out. So this is where we get our algebra hat on. So this is 2a plus 4ax squared plus 4bx plus 4c is equal to 8x squared plus 3x plus 9. I just copy and paste the g function. All right, so now is there anything that we can combine on the left side? Okay. Is there anything that we can combine on the left side? Not really, but I'm going to rewrite this a little bit. So this is 4ax squared. That's the first term, 4ax squared. Now plus 4bx, so that takes care of that. And now I'm going to put parentheses on this guy, so 2a plus 4c. It's not necessary to put parentheses, but I want to make sure that we see where things are going to go. All right, so let me put this in blue. Okay, so notice that in front of the x squared, you have this 4a. And so in front of the x squared on the other side of the equal sign, you have an 8. And so that's how we get this following blue equation. So 4a is equal to 8. So this blue equation was made by looking at what is in front of the x squared on both sides of the equal sign. Now I'm going to look at what's in front of the x. So I have a 4b in front of the x, and I have a plus 3 in front of the x. So I'm going to write down 4b is equal to 3. So that's my purple equation. That's where the purple equation is coming from. So again, we want to find the a, b, and c. And so we are matching quantities here. So this thing does not have any x next to it. And so also the 9 also does not have any x next to it. So that's how I get my third equation. So 2a plus 4c is equal to 9. All right, so 3 equations, 3 unknowns. So that means that we have enough equations to solve for a, b, and c. So let's start from the very beginning. So a definitely has to be 8 divided by 4, which is a 2. So we now know what the value for 2 is in the very beginning of our guess for the solution. All right, so that's a. Can we solve for b? For b, we have 3 divided by 4. Okay, so that's easy also. 3 divided by 4 is the number for b. Now for the last one, we have to do a little bit of surgery here. We have to plug in the 2 in for the a. Okay? We're going to plug in the 2 in for the a, and whenever we do that, we are going to get 4 plus 4c is equal to 9. Subtract 4 from both sides, then you're going to get 5 on the other side. And then c is going to be 5 divided by 4. So c is 5 divided by 4. So we now found the a, b, and c. So that means that we can write down the particular solution, and I'm going to write this in gold. Gold will always be my solution to the problem. So the particular solution is the a is a 2, so 2x squared. The b is a 3/4, that goes in front of the x, and then the x number c is plus 5 over 4. So that is my particular solution to the problem. That is my particular solution to the problem. All right, so just a quick review. We were looking at the g function, and we noticed that the g function in the red box in the very beginning, that g function is a quadratic function. And so we are going to guess that the solution to the problem is going to be a quadratic function. So that's why we have y is equal to ax squared plus bx plus c. And then we want to know what the a, b, and c are. So we find the first derivative, the second derivative, plug it into the differential equation, do the algebra, and then we get the a, b, c. And then finally we write down our particular solution. All right, so that's all I have for this. Now I want to, so this is the case where the g function was a polynomial. Now I want to give you another case where we have a trig function for the g. So this is a trig function for the function g. And again, we go back, before we try to make a guess to the solution, we always want to calculate the complementary solution. So let me look at the homogeneous equation. So the homogeneous equation is given by y double prime minus 2y prime is equal to 0. This, after you do the little algebra, you get the auxiliary equation, which is m squared minus 2m is equal to 0. And here you get m, and then n minus 2 is equal to 0. And so you get m is equal to 0 and m is equal to 2. So those are your two solutions to the algebraic equation, which means that your solution to the homogeneous equations are e to the 0x, which you can simplify this to be just the number 1. E to the 0 is just the number 1, so that's your first function. And then your second solution is going to be e to the 2x. So those are your two linearly independent solutions. That means that you can write down your complementary solution to be in this format. So C1 multiplied by the number 1 plus C2 e to the 2x. So that's your complementary solution. And again, for this type of problem, you have your complementary solution at the bottom, and then you want to focus on the g function that's given to you on the other side of the equal sign. And then you want to know, is that g function, is that inside your complementary solution? So that's question B. Okay. So question B, again, is asking you, is the g function, does that belong to the complementary solution? And then let me just write down the complementary solution just one more time. So C1 multiplied by the number 1 plus C2, and this was e to the 2x. So the question is asking us, are there any values for C1 and C2 such that if you choose C1 and C2 in particular, would it be able to give you this trig function, which is your g function? And the answer to this question is again no, which no for this question means that that's a good thing for us. It means we have to do a little bit less work. Okay, we still have to do some work to get to the final answer, but having no here means that we're good to make a good guess for part C. All right, so for part C, we want to find this particular solution, and then we know that our g function here is given by this trig function. And so the first thing that we want to say is what would a good guess be to the solution? So we are guessing here what the solution should be. And so someone might say, well, I think it's going to be a number multiplied by sine of 4x. Okay? And then that's a perfectly good guess. Okay, that's a perfectly good guess. But I want to tell you that whenever we get to the trig functions, our guess has to be a little bit more expanded. So it's going to be a cosine of 4x plus b sine of 4x. You cannot just plug in, you cannot just guess that it's going to be a number times the sine 4x. You also have to include the cosine part. All right, so that's, I'm telling you what the information here is. Okay, so now that you know your guess, you need to find your first derivative, your second derivative, and then you plug it into the differential equation, and then you want to figure out what the a and b are equal to. So that's our goal. Okay. All right, so what I've done is I wrote it down here for you. I typed it up, that way it's a little bit more clean. So here's our guess. It's a combination of cosine and sine. You find your first derivative. It's pretty straightforward. Your second derivative is pretty straightforward. Now you're going to plug in those three pieces of information into your differential equation. And so let me just kind of highlight where the things are coming from. So first of all, this blue box is your second derivative, and your second derivative is here in the equation, so that's why I plug in there. Now the other piece of information is that we need is the first derivative, which is this guy, and so that's what I have here. Okay, so that's my first derivative, and that's all I use on my left side. And then I just copy and paste my g function. So that's my g function, and I just copy and paste there. All right, so now what I need to do is I need to simplify this. So I also I type this up because it takes a while to write this lengthy item. And when you do these problems, it will take a little while to write it out. It's not difficult, it's just lengthy to do the calculation. And so I typed that up here for you. And so I distribute the -2 to the two terms, and then that's how I get plus 8a minus 8b. All right, so now we need to combine like terms. So things that have a cosine for x, I want to combine. So let me put that in blue. So this has a cosine for x, so that's a -16. This one has a cosine for x, and this is a -8b. So how much is that? So this is where I need to write down the following. So let me write it out this way. So negative 16a minus 8b, that was in front of the cosine for x. Now I need to look at the other pieces of information, which says in front of the sine for x, I have this negative 16b, and in front of the other sine for x, I have this plus 8a. So I'm going to write down the following. So plus minus 16b plus 8a, that was in front of the sine for x, and I make this equal to my g function, which is 3 sine 4x. All right, so now this is where we do the guessing game or the matching game. Okay, we want to match. Okay, so on the right side you have a sine for x, and in front of the sine for x you have this 3, and on the left side you have the sine for x, and in front of that you have this parentheses, which I'm putting in black now. So this is where you make those two things equal to each other. So negative 16b plus 8a is equal to the number 3. So that's how you get your first equation with the a and the b. Now how do you get your second equation? So for your second equation, I'm going to put this in green. So cosine of 4x, you have this green parentheses guy, which I'm putting in the green box. And then on the right side, there is no cosine, okay? On the right side of the cosine, you don't have any cosine, which means that technically it's a 0 multiplied by cosine 4x. So that's how I'm going to write down minus 16a minus 8b is equal to 0. Okay, so I make this equal to 0 because on the right side of the equal sign I don't have a cosine, so it's a 0 cosine, so just 0. Now I need to solve. I have two equations and two unknowns, so I need to solve for a and b, which we are able to. So let's work with the green one first. Okay, so that's negative 16a is equal to positive 8b. Now divide by 8 on both sides, so that's negative 2a is equal to b. All right. Negative 2a is equal to 2b. So that's one equation. We don't have the a and the b by itself, but at least we have a simpler relation for the a and the b. And so that means that we're going to substitute this into the b formula. And now I'm going to work with this. So this is going to be minus 16, and then the b is replaced with a minus 2a plus 8a is equal to 3. Now this becomes a positive 32a plus 8a is equal to 3. And if you do the arithmetic, then you'll get that will be a 40a, which gives you 3 divided by 40. Okay, so do the arithmetic and you get a is equal to 3 divided by 40. Now you will substitute this back into your green box, which is your formula for the b, and then the output of that is going to be the following. Let me put that in black. The output is going to be b is equal to multiplied by negative 2, that gives you a negative 6 divided by 40 for the b. All right, so now you know the a and the b. So what does that mean? So you have to kind of look at the big picture, and you have to realize that you were looking at the differential equation, which is in gold. This is your non-homogeneous differential equation, and then you wanted to find the particular solution to this guy. And so you made a guess in the very beginning. You were guessing that the solution was this combination of cosine and sine, but you did not know the a and you did not know the b, but now you do. So that means that we're going to write down the solution to this guy. So let me write it here on the very top. So the particular solution is going to be equal to, the a is 3 over 40, 3 over 40 cosine of 4x plus the b. Oh, the b is actually a minus. Okay, so the b is a minus. Let me put a minus here. So minus, and this is a what number? B is 6 over 40. 6 over 40 sine of 4x. A little crowded, trying to make it as bright as possible. All right, so that's the particular solution. You have your non-homogeneous differential equation, and then you made a guess that it was a combination of cosine and sine, but you did not know the a and the b. We did the algebra, and we got a and b, and so we can update our particular solution. And that's how you find the solution to this problem. All right, so now for the remaining of the questions, I'm going to tell you some things that we need to watch out for. Okay, so we're done with talking about how to solve this type of problems. So we talked about where the g function was a trig function. Like in this case, we have a trig function for the g. And the previous question, question number 3, I guess, was where we had g to be a polynomial. And the previous question was that before that was an exponential. All right, so now what about if you have the following situation? Okay, so suppose that you have a differential equation, but now your g function is like super lengthy. So you have this super lengthy g function, and so now you're like a little bit stuck. How do we figure out this very lengthy g function? Like, what should we guess to be the solution? So here is the idea. Okay, so we're gonna break the problem into 3 pieces. So 1, 2, and then 3. And what I mean by that is the following. We're gonna solve 3 different problems. Problem number 1 is going to be, here's your differential equation, y double prime minus y 5y prime plus 4y is equal to your 7e to the 2x. Second problem, you're gonna get the same differential equation, and now you're gonna make it equal to your polynomial. So 8x squared plus 3x plus 9. And now the third problem that you're going to create is the same differential equation, prime plus 4y is equal to your trig function 3 sine 4x. And here I want to make a little comment about we have dealt with this specific polynomial and we have dealt with this specific trig function, but don't try to recycle the information that you just got if your differential equation is different. Okay, if your differential equation is different than the problems that we just worked, then you cannot just recycle the information from before. It does not work. Okay, some people try to recycle just to get a shortcut, but there is no shortcut here. You actually have to solve 3 different problems here. And so here is the situation that we get. Okay, so for problem number 1, we are going to find the particular solution yp1. Okay, and if you had to think about it, you might want to guess that the particular solution is going to be something with e to the 2x. Okay, so a e to the 2x. But in order to make sure that that is a good guess, you have to look at the homogeneous, which here it will be the factors are -4, -1. So this is good. This is a good guess actually. It's a good guess. And so you find your particular solution, but you have to find the a there. Now for your second problem, you will make a guess to your particular solution, and I would also guess that it is a quadratic equation plus bx plus c. And that's a good guess. And here, the a that we have on this second problem, that a is not related to the a from the previous problem. So 2 separate problems. So the a are going to be 2 different numbers. Yeah. So you get your answers for a, b, and c, your values for a, b, and c, and then you get your particular solution for the second problem. Then you have to solve a third problem, and so you will get a particular solution for the third problem. Here, just notice that the auxiliary equation is going to have, let me see, -1, -4, so 1 and 4. And notice that, let's see, actually, yeah, I think it should work out. Okay, so 1, 4. So the guess here would be that you have a cosine of 4x plus b of sine 4x. But again, you have to double check that your g function is not part of the complementary solution. I don't think it is, but that's just briefly looking at it. So suppose that works, then you get your a and the b, different a than the other 2 problems, and then you get your particular solution. So that after you finish those 3 problems, which does take a little bit of time to solve each individual problem, then you can make your general solution. The general solution is going to be the combination. So it's going to be yp1 plus yp2 plus yp3. No constants here, okay? So it's just going to be whatever answer you get for the first problem, the second problem, then the third problem, add them up, and that addition is your general solution to the original problem from the very beginning. And that is what we call the principle of superposition. So superposition means that you kind of break up the problem into smaller pieces. So problem 1, 2, 3 are the smaller problems. And then once you solve those small 3 problems, which are lengthy, then you can solve the big problem, the big problem in the very beginning. and then it is literally just the sum of the solutions. All right, so that's one thing to watch out for. All right, so now let me go into the next type of situation that we might have. Okay, so here I'm not going to solve the problem, but I want to see what a good guess for the solution should be for this problem. So again, we look at the homogeneous equation, and let me write down the homogeneous equation. So y prime plus 4y is equal to 0. Then you get your auxiliary equation for 5m plus 4 is equal to 0. And then we got the values to be m is equal to, let me see, m minus 1 minus 4. So m 1 and 4. Okay, so m is equal to 1 and 4. And notice that means that the y1 solution should be e to the x, and then this y2 solution should be e to the 4x. And what do you know now about this y2 function? Compare that to the g function that you have. So this is the part B in the previous problems. Part B was asking us, is the g function essentially in the complementary solution? So is the g function essentially either the y1 or y2? And in the answer in this case is yes. So that means that whenever we want to solve the differential equation that we have, whenever we want to solve the ordinary differential equation that we have, we want to make a guess. So the good guess here would be that the particular solution should be a multiplied by x e to the 4x. So we have to put in this extra x here. We have to put in this extra x here. That's because the g function is already either the y1 or the y2. Okay, ignore the 8 that you have here. All right, so that's one thing that we already covered, but I'm just repeating what we need to be careful with. All right, so now let me go to the next question. So again, the task here is to make a good choice for the particular solution. All right, so now again, let's look at the the homogeneous equation. So y double prime minus 8y. Oh, this should have been a prime here and a y here. So apologies for that. So that this should have been 8y prime plus 16y is equal to 0. All right, so now we look at the auxiliary equation related to this. So m squared minus 8m plus 16 is equal to 0. And so now we want to see if we can factor this out. Can we factor this out? And in this case, we can. So this will be n minus 4 times n minus 4 is equal to 0. Equal to 0. That means that we have repeated roots. Okay, and then whenever we have repeated roots, we have one solution to be e to the 4x. And then how do we find the second solution? Well, the second solution, we have to use the reduction of order. So let me just review that for you, or the name, reduction of order. To find the second solution, we have to use reduction of order, and then we get x e to the 4x after we do the process. Okay, so make sure you review that part also. All right, so now what do you notice? What do you notice about the g function? Okay, so the g function, ignore the 8, just look at the x e to the 4x. So that's your g function. And notice that the g function essentially is your y2. It doesn't matter that it's y2. It could have been y1, flip-flop, the y1 and y2, relabel them. But it just means that the formula that you're seeing, x e to the 4x, appears as the solutions to the homogeneous equation. So that means that we have to be very careful on our choice for the particular solution for the original differential equation. So here is the differential equation from the very beginning. This is the full problem that we want to solve. And then we want to guess that the solution to this problem is going to be the following. So it's going to be a, but we are going to multiply by x squared e to the 4x. All right, so this is the tricky part. This is no longer just multiplied by x, it's multiplied by x squared e to the 4x. So that would be a good guess to the particular solution to this problem. And then our goal now is to find the a. But the hard part is, the tricky part is that we have to make a good choice for the solution. All right, so now one more type of problem. Okay, so again, same problem is asking us what is a good choice for the particular solution. All right, so now let's look at the homogeneous equation. So y double prime plus 4y is equal to 0. That's the homogeneous equation. We do the little bit of algebra and we get the auxiliary equation is equal to 0. Now this one is going to have two solutions that are complex solutions, so plus or minus 2i after you do the algebra. So those are your two values for m. So that means that you have y1 to be e to the 2ix, and then y2 is equal to e to the negative 2ix. And what I want to remind you is that sometimes depending on what you're dealing with in your career, if you're an electrical engineer, you probably do want to use exponential functions that have the I in there. But if you're dealing with something that is like a physical property that has no complex numbers related to it, then you want to find the other versions of the y1 and y2. So we're going to replace the y1 and y2 with the following two formulas. So cosine of 2x and y2 is going to be sine of 2x. All right. So this is what we did in the previous section, which was on the linear homogeneous constant coefficient differential equations. It's a mouthful, but that's what we did in the previous section. All right, so now that's your y1 and y2, and then from there you get your complementary solution. And so now what we want to say is the following. You look at the g function that's given to you. Look at the g function that's given to you. It's a g function essentially in the y1 or y2. In this case, it is the y1 function. So this means that we have to be careful with what we are going to guess that the solution is to this problem. So we want to make a good choice for the particular solution to the solution of this differential equation that is non-homogeneous. So a good guess will be the following. So we're going to guess that it is going to be a combination of, so let's call it ax cosine 2x plus bx sine 2x. Let me put that in red. All right, so this will be a good guess to the solution of this differential equation. All right, so now the task is to figure out what the a is equal to and what the b is equal to. So we've done the process several times now, but I just wanted to emphasize that making the good choice for the particular solution is sometimes tricky. And it's tricky because we first have to look at the homogeneous equation. We have to look at the complementary solution. All right, so that's all I have for today. I hope you enjoyed this, and I'll see you next time.